Chapter 3, Number 8. You walk in a straight line for 95 meters at an angle of 162 degrees above the positive x-axis. What are the x and y components of your displacement? Alright, so let's draw an axis. Traditionally like that. And then this phrasing is a little strange because it says that we are at an angle which is 162 degrees above the positive x-axis. So what we're going to do is start at the positive x-axis and then go 162 degrees up. So we go 90, and then we go almost another 70. So we end up something like that. And that's 162 degrees. So that's perfectly fine, but it's kind of weird to phrase it that way. Math people would usually say as measured from the plus x-axis, not above the plus x-axis. But there we go. And we know that we have a distance which is 95 meters. And what we're looking for are the y and x values of that. Now, since we are measured from the plus x-axis, it turns out life is relatively straightforward. We know that x is going to be, if we give this thing the size just named a, x is going to be a cosine theta, and y is going to be a sine theta. And if we're measuring from the plus x-axis, this is always the case. And I don't have to think about triangles or anything like that. So we run through and we say 95 cosine 162 and 95 sine 162. And we have only two sig figs, so we end up with minus 90 exactly, right, 90 point meters, and minus and plus 29 meters. And those are our within two sig figs, those are our answers. You can do this a slightly different way if you want to work through right triangles, so I'm going to do the problem over doing that. To avoid confusion in our symbols, I'm going to work with different names here. I'm going to work with this right triangle, and I'm going to call one side of that triangle H and the other side S. And I'm just avoiding x and y because I used them in the last one, and we'll see there's a subtlety here that's sort of important. Also, we know that this is a right angle, which is great, but what I need is this angle, because the 162 degrees really can't be in a right triangle. But this angle plus this angle have to be 180 degrees, and therefore this angle has to be 18 degrees. So I really have a triangle whose hypotenuse is 95, whose angle is 18, and whose sides I want. So I say, well, the cosine of 18 is defined as the adjacent over the hypotenuse, or S over 95. So S is going to be 95 cos 18, which turns out to be 90. And sine of 18 is defined as opposite over hypotenuse, and so that's H over 95, which says H is 95 sine 18, and that's 29. And you might say, well, those are almost the same thing, but I had a negative before. And the issue here is that our sides are always positives, but we know that if we go back to the triangle, the component for x is in the points in the negative direction. And so the x component is minus s here. It's minus 90 meters. Whereas for y, the component points upward, and so y is the same as h, which is 29. Either of these are perfectly acceptable ways to do the problem, and it really comes down to which one you're most comfortable with. But it is important at some point to verify that your components have the plus or minus that is appropriate for the way they actually point.